Yeah, can you see my screen now? Yeah, are you able to see the screen now? Okay, so having got the value of beta from here, sorry, the connection got lost. Roughly, I'll put it over here. So r square would be 16 divided by 0.254. Okay. For practical purposes, you can take this as 1 by 4. Okay. So r square can be taken as 16 divided by 1 by 4, which is 64. Oh, okay, okay. I understood. I understood the problem here. So basically, you don't have to do this because, as he rightly pointed out, this will be 65, not 64. Okay. So we'll resume from here. That makes our life very easy because then it will be a case of then we don't have to do all these things. Then it will be a case of a factorizable quadratic. So you can write this as this minus 64 beta minus beta plus 16 is equal to 0. So 4 beta minus 16 minus 1 beta minus 16 is equal to 0. So beta is 1/4. Okay. So it's exactly 0.25. Okay. So from here I can get the value of r. R will be nothing but under root of 64, which is going to be 8. Okay. Is that fine? Okay. So let's move on to the next question now. Find the values of the following trigonometric ratios. Evaluate number one, cos 495 degrees. Can you see now? All right, sorry. Again, the net connection is not proper today. All right, so let's quickly discuss this. The first one, cos of 495 degrees, right? So 495 lies in which quadrant? First of all, let's try to identify the quadrant in which 495 lies. So 495 will lie in the second quadrant, correct? Correct. In the second quadrant, the value or the sign of cos is going to be negative, correct? Next, 495 could be written as 3 into 180 degrees minus 45 degrees, correct? So its value here is going to be cos 45, that's going to be negative 1 by root 2. Okay. Quickly doing the next one also, sine 1230 degrees. So 1230 degrees would lie, let's say I complete one round 360, two round 720, three round 1080. 1080 plus 90 is 1000. So I'm here at 1080. So if I complete 90 more, I will be 1170. Okay, and then 60 more again. So I'm back to the second quadrant where sine is known to be positive. Okay. So I can write this as 1230 degree as 7 times 180 degrees. So 7 times 180 degrees will make it 1260 minus 30 degrees. So this will be as good as plus sine 30 degrees, which is going to be plus half. Is that fine? Okay. Talking about cot minus 315 degrees, we know that it's as good as saying minus cot 315 degrees. Yeah, can you see now? Okay. Let's solve the fourth one also. Fourth one, this is going to be minus tan of 1590 degrees. Correct? So 1590 degrees lies in which quadrant? Let's figure that out first. So 1590 means you have covered around four rotations, okay? And four rotation means you have covered around 1440 degrees, correct? Okay, and this is 150 more than that, so you're back to the second quadrant. Okay, so 150 degree more than that will take you to the second quadrant. In second quadrant, again, tan is known to be negative, so it's going to be negative tan. Now this is 30 degrees, so you'll have tan 30 degree over here, so that is going to be plus 1 by root 3. Okay, that's going to be plus 1 by root 3 as your answer. Is that fine? Next question. If tan 35 degrees is equal to A, okay, prove that tan 145 degrees minus tan 125 degrees whole divided by 1 plus tan 145 degrees tan 125 degrees is 1 minus A square by 2A. Is that done? All right, so let's discuss this now. So we can write tan 145 degrees as tan of 180 degrees minus 35 degrees, correct? And we all know that tan 180 minus theta is minus tan theta, so it is minus 35 degrees, which is negative A. Okay. Similarly, tan 125 degrees could be written as tan of 90 degrees plus 35 degrees. Okay. We know tan of 90 plus theta is going to be minus cot theta. So it's minus cot 35 degrees, which is nothing but minus 1 by A. Okay. So now putting it into the left hand side of the expression, now substituting this in left hand side of the expression, What do we get? Minus a minus of minus 1 by a divided by 1 plus tan. That's nothing but 1 minus a square upon 2a. That's equal to your right hand side. Guys, can you see the screen now? Okay. All right. So let us move on to the next question now. Next question is, if cos of alpha plus beta is equal to 4 by 5 and sine alpha minus beta is 5 by 13, where alpha and beta both lie between 0 to pi by 4. Okay. Find the value of tan of 2 alpha. Find the value of tan of 2 alpha. Done? Anyone? Please type in the response in the chat box once you're done. So how do you get the value of tan 2 alpha given that cos of alpha plus beta and sine of alpha minus beta is given to you? So let us understand this. We can write tan of 2 alpha as tan of alpha plus beta plus alpha minus beta. Correct? Now treat this as your A angle, treat this as your B angle, so which falls into the formula of tan A plus B, which you can write it as tan A plus tan B by 1 minus tan A tan B. 1 minus tan A tan B. correct? But even to find this, we need the value of tan alpha plus beta and tan alpha minus beta, correct? Now, we know that since alpha and beta both lie in the interval 0 to pi by 4, alpha plus beta will also lie in the same, alpha plus beta will also belong to the first quadrant. Okay. This is very important to know because it will decide what will be the sign of the trigonometric ratios that we are going to get. Yeah. Yes, exactly. That's what we can take, Venkat. We can take sine alpha plus beta now to be 3 by 5 without any problem. Okay. Else there would be a doubt whether it would be 3 by 5 or a minus 3 by 5. Now that we know that it lies in the first quadrant, we can take such calls very, very easily. In a similar way, I can say cos alpha minus beta could be written as 12 by 13. Okay. And this implies my tan alpha plus beta, which is nothing but sine of alpha plus beta by cos alpha plus beta, can be directly written as 3 by 4. Okay. And here I can write sine alpha minus beta by cos alpha minus beta. That is going to be tan alpha minus beta as directly, I can write this as 5 by 12. Once I know these values, I can directly substitute over here. So please substitute these formulas over here. When I do that, I get the value as tan alpha plus beta is going to be 3 upon 4, and this is going to be 5 upon 12 by 1 minus 3 upon 4 into 5 upon 12. Okay, which gives you 36 plus 20, which is 56 by 48 minus 15, which is 33. So your answer is going to be 56 upon 33. That's going to be your answer. Is that fine? Let's take the next question. If a plus b is equal to pi by 4, find the value of find the value of 1 plus tan a into 1 plus tan b. If you're done, please type in the response in the chat box. Okay, so let's quickly discuss this as well. So I can always write angle B as pi by 4 minus angle A, right? So let us write this term as 1 plus tan A times 1 plus tan pi by 4 minus A. Okay. So this becomes 1 plus tan A, and this becomes 1 plus, this is 1 minus tan A by 1 plus tan A. Correct? Let me take an LCM over here. So this becomes 1 plus tan A and 1 minus tan A. Okay? Tan A and tan A gets cancelled. In fact, 1 plus tan A and 1 plus tan A also gets cancelled, leaving you the answer as 2. So this becomes actually 2. Is that fine? Yes, correct. Venkat, answer is 2. Absolutely. Let's take another one. Find the value of find the value of tan x into tan x plus pi by 3 plus tan x plus pi by 3 into tan x minus pi by 3 plus tan x minus pi by 3 into tan x. Find the value of means you'll get a number, you get a numeric answer for this particular expression. Any idea? Okay, I'll just give you a hint here. Just do this operation tan A tan B plus 1. Okay. Yeah, yeah, take your time. All right, take your time, no worries. This is a very good problem actually. See, if you do this operation which I gave you a hint to do tan A tan B plus 1. Okay. When you do that, you realize you get sin A sin B by cos A cos B plus 1. Correct? If you take the LCM of cos A cos B, you get sin A sin B plus cos A cos B. Right? This clearly is the formula of cos A minus B by cos A cos B. Okay. Now let us try applying this to all these terms. Let's add a 1, 1, and 1 to each of these terms and subtract a 3 over here. Okay. Now this fits into this formula of 1 plus tan A tan B. Okay. So I can write this as cos A minus B, which is pi by 3, divided by cos x plus pi by 3. Okay. By 3 divided by cos x minus pi by 3 cos x plus pi by 3. Okay. And in a similar fashion, this can be written as cos pi by 3 divided by cos x minus pi by 3. Okay. And you have a minus 3 outside over here, which is this minus 3. Okay. All right. So now what I'm going to do is I'm going to club these two terms together. Okay, and I'm going to first pull out a cos pi by 3. Cos pi by 3 we all know is half, so I don't have to write cos pi by 3 every time. So 1 by 2 cos x I can pull out, correct? So it'll become 1 by cos x plus pi by 3 plus 1 by cos x minus pi by 3. Okay, this term I can write it as negative 2. Okay, now we all know the formula of cos a plus b into cos a minus b, correct? What is the formula? Cos a plus b, cos a minus b, cos square a minus sine square b. Or you can say cos square b minus sine square a. Correct? So I can directly apply that over here. So I can say this formula can be written as cos square pi by 3 minus sine square x. Okay, minus a 3. Let's simplify this. So this becomes 1 by 2 cos x. Okay. Here I would get cos x plus pi by 3 plus cos x minus pi by 3 divided by cos x plus pi by 3 cos x minus pi by 3. Okay. And this term will remain as such. So this is going to be cos square pi by 3 minus sine square x minus a 3. Okay. Now let us simplify this. This term will become 2 cos x cos pi by 3. Okay. And this will remain as such. By the way, here there is no point to convert it like this. We can keep it as cos x plus pi by 3 into cos x minus pi by 3. Okay. So this gets cancelled, cos x gets cancelled, and we know that cos of pi by 3 again is a half. So it's half of cos x plus pi by 3 into cos x minus pi by 3. And here also I have 1 by 2 cos x plus pi by 3 cos x minus pi by 3. Okay. These two terms will get cancelled off, and I will be left with 3 minus 3 as the answer. So your answer is minus of 3. So this becomes your answer. Okay. Very good question. Can come in your UTs, but it's very lengthy actually. Okay, so please make a note of this. We'll move on to the next question. Yes, it may be a 6 marker. You're correct. It can be given as a 6 marker. If tan beta is n sine alpha cos alpha by 1 minus n sine square alpha, show that tan of alpha minus beta is 1 minus n tan alpha. Yeah. Let me know once you're done. You didn't get it? What about others? Okay, let's try it out. Let's start with tan alpha minus beta. Tan alpha minus beta, you can write it as tan alpha minus tan beta by 1 plus tan alpha tan beta. Okay? Now let tan alpha be as such, and tan beta could be replaced by this value. So let this value replace your tan beta. So you'll get n sine alpha cos alpha by 1 minus n sine square alpha divided by 1 plus tan alpha. Okay? Times n sine alpha cos alpha by 1 minus n sine square alpha. Okay? Write this tan alpha as sine alpha by cos alpha. Sine alpha by cos alpha. Okay. In fact, we can write this tan alpha also as sine alpha by cos alpha. Okay. Now, cos alpha and this cos alpha will get cancelled off. So let me simplify this. So it becomes sine alpha 1 minus n sine square alpha minus n sine alpha cos square alpha. Okay. In the denominator, I will have 1 minus n sine square alpha plus sine, you can write this as n sine square alpha. Is that fine? Just check once. Everything is fine so far. Okay. Now, this term gets cancelled with this, and I can take a sine alpha common. Okay. I get 1 minus n sine square alpha minus n cos square alpha. Okay. And by the way, we'll have in the denominator one cos alpha coming up. So this I missed out. Yeah. So this will be cos alpha. Because here we cancel out a cos alpha. So these two terms are gone. Right. So when you take the LCM up, in the up you will have this whole divided by, let me explain you what I did here. This whole divided by cos alpha 1 minus n sine square alpha. And here in the denominator, I'll just have 1 minus n sine square alpha. Correct? So what will happen is that this cos alpha will remain. Okay, that's what I have written over here. This cos alpha will remain. Okay. So it will be cos alpha into 1. Okay. Now from these two terms, if you take a negative n common, you get sine square alpha plus cos square alpha. Okay. Which is nothing but 1. So this will become tan alpha times 1 minus n, which is nothing but your RHS. So this is what we wanted to prove over here. We wanted to prove that it is 1 minus n tan alpha. Is that clear? Next question. If 3 tan theta minus 15 degree is equal to tan theta plus 15 degree, where theta lies between 0 to 90 degree, find the value of theta. Find the value of theta. 30 degrees, no, that's not the correct answer. Venkat, are you watching in a lag? Because I'm already on the next page and I've not written anything on this page. Just it is the top part of the page. Forty-five degrees, that's correct. Did you guess it or did you solve it? Manav, was that a guess or did you solve it? Okay, so let's try to solve this now. So we have been given that tan of 15 degree. Okay. Uh, Sorry, tan of theta plus 15 degree by tan of theta minus 15 degree is equal to 3. Okay. Yeah. So this is as good as saying sine theta plus 15 by cos theta minus 15. Sorry, theta plus 15 and sine theta minus 15 into cos theta minus 15 degree is 3 by 1. Okay. Right. So now we can do one thing. We can apply componendo and dividendo over here. So I can do cos theta plus 15 cos theta minus 15. Okay. Plus cos theta plus 15 sine theta plus minus 15 whole divided by sine theta plus 15 cos theta minus 15 minus cos theta plus 15. This will be this, correct? Okay. Oh, I'll take it to the previous slide, Venkat. No worries. Okay, let's first finish this off. Now this is going to be sine of theta plus 15 plus theta minus 15 divided by sine theta plus 15 minus theta minus 15. Okay, that's going to be 2, which implies sine 2 theta divided by sine of 30 degrees is going to be 2. So sine of 2 theta is going to be 2 into sine 30 degree. That's going to be 2 into half, which is nothing but a 1. Correct? Now sine of 2 theta is 1 implies 2 theta has to be 45 degrees. Sorry, 2 theta has to be 90 degrees because it's given that your answer should lie between 0 to 90 only. So theta has to be 45 degrees for this. Is that fine? Any questions with respect to this? Okay, next question. Venkat, I'll take you to the previous slide now. If you want to copy something, you can copy. So this is the previous slide. So just understand the process. What I did was I converted tan alpha to sin alpha by cos alpha, and tan beta is substituted with whatever was given to me in the question. And then if you simplify, you'll automatically get the answer. Okay, next question is, if m tan x minus pi by 6 is n tan x plus 2 pi by 3, then prove that 2 times m minus n is m plus n sec 2x. Try this out. Let me know once you're done. Just type done on your chat box. Okay, only Venkat could do that. What about others? Again, same stuff. Just do m by n first. M by n will be what? Tan x plus 2 pi by 3 divided by tan x minus pi by 6. Okay? Just write this in terms of sine and cos. So sine 2x x plus 2 pi by 3 by cos x plus 2 pi by 3 sine x minus pi by 6, and you'll have cos x minus pi by 6. Now, again apply componendo and dividendo. Okay? So m plus n by m minus n. Okay, so let's do that. So for the time being, I'll consider this to be A, this to be B. So again, this is A and this is B, just so that I don't have to write much. So it's sine A cos B plus cos A sine B, and in the denominator I'll have sine A cos B minus cos A sine B, which is clearly the formula for sine A plus B by sine A minus B. Okay, and sine A plus B means addition of these two terms, that will give you sine x plus 2 pi by 3 minus pi by 6. Okay, 2 pi by 3 minus pi by 6 will be pi by 2 divided by sine A minus B. A minus B will be 2 pi by 3 plus pi by 6, which will be 5 pi by 6. So this will be m plus n by m minus n. Okay. Now sine 90 plus x is cos x. Okay. Okay. I'll have a 2 over here. Sorry. So it's cos 2x. Okay. And in the denominator, I'll get a half. Right. So 2, this can be written as 2 by sec 2x is m plus n by m minus n. Okay. Let's cross multiply. When you cross multiply this with this, you get 2 times m minus n as m plus n sec 2x. And I think this is what we wanted to prove actually. Let's check up. Let's go up and check. Yeah, this is what we wanted to prove over here. Is that fine? Okay, let's take one more question and then we'll move on to sets chapter. Prove that 1 plus tan x by 2 is sec x, and this in turn is tan x cot x by 2 minus 1. Prove that tan x 1 plus tan x by 2 is sec x, and that in turn is also equal to tan x cot x by 2 minus 1. Done? Yeah, Harin, I'll go back to the previous slide. First, let's do this question. Done? Okay. How about others? Done. Advaita is also done. Okay. So let us start with proving this is equal to this. So 1 plus this I can write it as sine x by cos x, and this becomes sine x by 2. Sorry. Sine x by 2 cos x by 2. So I'm starting from my left hand side. Okay. Yeah, so this becomes cos x by 2, and this is cos x by 2 plus sine x by 2, which is clearly the formula of cos a cos b plus sine b, which is cos a minus b, divided by cos x by 2. Okay, that's nothing but cos x by 2 divided by cos x by 2. These two gets cancelled, and that is nothing but sec x, which is actually equal to your right hand side. Now to also apply the same, so tan x by 2, tan x into cot x by 2, let me write it as sin x cos x by 2 divided by cos x sin x by 2. Okay, minus 1, that will become sin x cos x by 2 minus cos x sin x by 2 divided by cos x sin x by 2. Okay, this is nothing but the formula of sin x minus x by 2 divided by cos x sin x by 2. Correct? And this is nothing but sin x by 2 divided by cos x sin x by 2. Cancel off sin x by 2 both from the numerator denominator. You will get sec x as your answer. Right? Quite easy problem. Now let us talk about sets for the time being. Okay. In sets, basically, the following concepts are important. First of all, you need to know what is a set. Okay. Because they can give you a question as to whether that particular collection of object is a set or not. Okay. All of you must know that the definition of a set is, what's the definition of a set? Set is basically a collection of well defined. It's a collection of well defined objects. Okay. This well defined is very important because there should not be any ambiguity in the definition of a set. So it's a well defined collection of objects which is called a set. Okay. So they may ask you this question. Tell me whether a collection of all beautiful girls in India, all beautiful girls in India, is this a set or not? Just type yes if it is a set, no if it is not. No, it is not a set because beautiful is a very subjective term, right? This is not well defined. Who defines what is beautiful and what is not beautiful? Okay. Next, let's say all big cities of India. All big cities of India. Is this a set or not? Okay. This is also not a set. Correct. All intelligent, all intelligent students of NPS. Is this a set or not? No. Again, the word big, the word intelligent, they are not well defined. Are you getting this point? So when such collection of objects are given to you have to tell it is not a set, right? But if I say all colors of rainbow, all colors of the rainbow, this is a set because there are seven defined colors vibgyor in a rainbow. Is that fine? Okay. Next is the representation of set, which is there are two representations of set. One is called the Rooster form, and other is called the set builder form. Is it now visible? Can you see the screen, everyone? Hello, am I audible? Okay, fine. So I'll just take a quick question on converting Can you hear me now? None. So what's the answer? So you just have to put the values. So it's 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7, 7 by 8, 8 by 9, 9 by 10. Don't worry, it should be visible now. Just 1 second, it should be visible now. Are you able to see the screen now? Okay. Let's take another question. Write the set builder form for set A defined as let's say 0, 6, 24, 60. Write a set builder form for this notation. n cube minus n, absolutely correct. So basically in set builder form, you can write this as x, where x is n cube minus n. Okay. Yeah, and people who have done your mental ability in NTSC will find this very easy. Okay. Next type of question that is framed on set is about subsets. So all must be clear with the subsets. When is A called a subset of B? A is a subset of B if all elements of A also belong to B. Okay. Now, if set A has n elements, the total number of subsets that can be formed is 2 to the power n. How to do this? It's very simple. Let's say A has these elements A1, A2, A3, all the way till AN. Okay. Now, if you want to form a subset of A, okay, let's say a subset of A has to be formed. Let's say there is a subset of A. Okay. If a subset of A has to be formed, every element here will have two options. Correct? So A1 will have two options, A2 will have two options, A3 will have two options, all the way till AN. Correct? So the number of subsets of A can be obtained by multiplying 2 into 2 into 2 n number of times. Okay. So we say 2 to the power n number of subsets are possible for set A. Is that fine? Okay. Now there's something called proper subset. Okay. What's the proper subset? Proper subset is a subset where at least one element of that set B should not belong to that subset. Okay. When, let me write it in terms of language. If A is a proper subset of B, if A is a proper subset of B, okay, then at least one element of A does not belong to, sorry, one element of B does not belong to A, does not belong to A. Are you getting it? So let me take an example. So let's say A is, let's say B is not A. Let's say B is 1, 2, 3. Okay. Now the subset of A can be, the subset can be 1, okay, it can be 2, it can be 3, it can be 1, 2, it can be 1, 3, it can be 2, 3, it can be 1, 2, 3. Correct? It can also be a null set. So altogether there will be 8 elements, 1, 2, 3, 4, 5, 6, 7, 8. Correct? Out of this is called the improper subset because it has got all the elements of set B. And all the remaining ones, which I'm marking with a tick mark, they are proper subsets. So these all are proper subsets. Okay. So as a rule, we say that if the number of elements in a set A is n, then the number of proper subsets, then the number of proper subsets is equal to 2 to the power n minus 2 to the power n minus 1. Is that fine? Okay. Now, questions that can come on proper subsets and subsets. Let's take that. Let A and B be two finite sets. Let A and B be two finite sets such that A has m elements and B has k elements. Okay. The total number of subsets of A is 56. The total number of subsets of A is 56 more than the total number of subsets of B. Okay. Find the value of M and K. 64. What is that doubt? Mahak, what is your doubt? Okay, so you're correct. So basically, let's solve this. So total number of subsets of A would be 2 to the power m. Okay, and total number of subsets of B will be 2 to the power k. Correct. So 2 to the power m will be 56 plus 2 to the power k. So 2 to the power m minus 2 to the power k will be 56. Correct. Now it's very obvious that m is greater than k, right? Oh, that we converted to a rooster form or that we converted to a set builder form? How does x lie between 1 to 9? Not x, it's n that lies between 1 to 9. Sorry for the misprint there. Now it is clear. Okay. Now from this it is very clear that this is an even number and this is an odd number. Okay. And this even number is some power of 2. So basically it's very obvious that this has to be split up as 8 into 7. Which clearly implies 2 to the power k is 8 and 2 to the power m minus k minus 1 is 7. Which means k is 3 and 2 to the power m minus 3 is equal to 8. So m minus 3 is also equal to 3 because this can be written as 2 to the power 3. So m is equal to 6. So the answer is k is 3 and m is 6. Okay. Next important concept is the concept of power sets. Okay. Power set of a set A is basically nothing but it's a set which contains all subsets of A. Okay, I'll give you an example. Let's say A is 1 comma 2. Okay, I want to write the power set of A. This is how we represent the power set of A. So what I'll do is I will write all the subsets of A possible, which is null set, set containing 1, set containing 2, set containing 1 and 2. मैं क्यों नहीं होगा? Because n will go till 1 to 9, right? Including 9. So 9 by 10 would be there. What is wrong in that? Okay. Now, just a quick question for you. If A is a set containing only 1, write down the power set of A. Done? Okay, now let's solve this question. Now power set of A will contain only two elements, null set and the set 1 itself. Correct. Now when it comes to power set of a power set of A, we have to start writing the subsets of this. Now, subset of this will contain null set, a set containing null set, a set containing 1, and a set containing null set and 1 itself. This is very important. Many people have a confusion regarding this. They say, sir, isn't these two the same thing? Please note that null set and a set containing null set are not the same things. They are different things. This is like a empty box, and this is like a box containing an empty box. Are you getting it? There's a difference between these two. Are you getting it? Please note couple of things. Set containing 1 and a set containing the set 1. Please note they are two different things. They are not the same. Okay. Here, this is a set which contains 1 as the element, and this is a set which contains set 1 as its element. Okay. Are you getting this point? Okay. Let's take a very interesting exercise. Okay. Let A be a null set. Let A be a null set. Okay. Find power set of power set of power set of A. Done? Okay, let's discuss. So, first of all, what will be power set of A? Power set of A will basically contain a set which contains the null set itself. Okay. Now, what will be power set of A? It will contain a set which contains the null set and the set of null set. Are you getting this? Okay. Now, what will be power set of power set of power set of A? So, it will be a set containing null set. Okay. A set containing null set. A set containing the this. Okay. And a set containing these two elements. Is that fine? Okay. So please note, they're all different things. They may all look very similar, especially these three look similar, but they're not. They're different things. This is a null set element. This is an element which is a set of a null set. Are you getting this point? Very important. Now, next is the concept of union, intersection, which you all know. I don't have to tell you all that things. One important thing is the difference of sets. This is important. Difference of sets, which is written as A minus B. Right? It is to be read as all elements X such that X belongs to A and X does not belong to B. Okay, please note that A minus B is same as A intersection B complement. This is a very important relation. Okay. Now, most probably the questions that you will get would be practical problems on sets. Okay. Or we say problems based on cardinal number. Problems based on cardinality of sets. Okay. So all of you must be familiar with these formulas: NA union B, that's NA plus NB minus NA intersection B. Okay. NA union B union C is nothing but which what do you want to do in a reliable way? Okay. NA minus B would be nothing but NA union B minus NB. Okay. Right. NA minus B is basically this part. This is set A and this is set B. This is called A minus B. This part is called A minus B. Okay. Okay. And this part is called, the yellow part is called NB minus A. You can also write this as NA minus NA intersection B. Okay. Similarly, you can write NB minus A as NA union B minus NA. Or you can write it as NB minus NA intersection B. No, for power set, you just have to write down the subset of that set, okay? And just put all those elements in a curly bracket. Okay? Got it, Venkat? Okay. Now, basically, all these theorems you can directly prove from Venn diagrams. Okay. So, when you say NA union B is equal to NA plus NB minus NA intersection B, you can prove this by Venn diagrams. So, let's say we have this as set A, this as set B. Okay. Let's say this part, let me show this by yellow part. Let's say this is M. Let's say this part is N. And let's say I change the color. This part here is O. Okay. Now see here. When you say N A union B, it's actually nothing but M plus O plus N. Okay. Now according to this formula, NA is nothing but M plus O. Correct? This is NA. NB is nothing but M plus O. Right? And A intersection B is nothing but O. Correct? So if you do N A plus NB minus NA intersection B, you end up getting M plus O plus N plus O minus O, which gives you nothing but M plus O plus N, which is what had written over here. Okay. So all of these questions you need not do, you do not remember these properties. You can directly do it. Okay, I'll go back to the previous slide, Harin. 1 second. Is that fine? Let's take practical problems which you can solve by using Venn diagrams. Have you done these type of questions in your school? Practical problems on Venn diagram. They say so many number of students take physics, so many number of students take chemistry, like that kind of problem. Have you done that in school? Okay. So most likely those problems are going to be asked for tomorrow's test. Okay. So I'll just run you through a few of them. Okay, let's start with this question. Are you sure? Then what type of problems have been done in your school for sets? So what is left in sets then? Have you done the properties? Prove that questions. Oh, acha, 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 acha. Only problems related to that. Okay, fine. Then we'll do problems related to that only, rather than doing anything extra. Okay, fine. So I'll give you problems related to a rooster set, set builder form, etc. Okay. If let's say set A is basically the set of all alphabets of the word poor. Write down the power set of A. Write down the power set of A. Power sets are basically a set of subsets of A. Okay, so first write down A. A will be nothing but P O R. Please remember, in a set you cannot write one element more than once. So even if there are two O's, you have to only write one O. Okay. Yeah, that's correct. That's correct. Manas. Manav, sorry. So what are the subsets of A? Subsets of A would be a null set, a set containing P, a set containing O, a set containing R, a set containing PO, a set containing PR, a set containing RO, and a set containing POR. So 1, 2, 3, 4, 5, 6, 7, 8. Correct? All you need to do is you have to put them all in a curly bracket, and this would become the power set of A. So please note the number of elements in the power set of A is same as the total number of subsets of A. So basically, this is very important formula for you. Is that fine? Okay. Next question. If A is 1, 2, 3, 5, 6 and B is 2, 3, 4, 7, 8, write down the set A minus B. Done. Yes. So basically, from A, remove the elements which are also there in B. So 2 and 3 are in B. So your answer will be 1, 5, 6. Okay. Easy one. Let's take another question. If A is a set which contains 1, 2, 3, 4, 5, 6. Okay. Then state true or false. State true or false. Statement number 1 or statement number A. 1 is a subset of A. Statement number B. This is a subset of A. Statement number C. This belongs to A. Statement number D. 1, 2, 3 is a subset of A. Okay. When you're writing your response, write it like this: A is true, B is true, C is false, like this. Please state your response like this, okay? So that I know which statement you are writing as true or false. So now I can see a lot of response coming, but you are writing it separately. I would request you to write in one go. A true, B true, C true, D false, like this. Please write the response like this. Don't give individually one response. In one go, you write this. One go in your box, you write this in one go. So Vidyut says A is false, B is false, C is true, and D is true. Okay. D and D. Okay, let us discuss this. Let us discuss this. A says 1 is a subset of A. This is a false statement. You can say 1 belongs to A. 1 is not a set. right? If you want to write it, you have to write it as this. This is a subset of A, but 1 belongs to A. Okay, so this statement is a wrong statement. Is that fine? So those who are saying A is true, I'm so sorry, A is not true, A is false. Second is, this is a subset of A, this is also false. Because this is an element. So basically, this will belong to set A. Right? But if you want to write it as subset, you have to say set of this will be a subset of A. Okay, so this statement is also false. Okay, this is true. This is also false because this is now a subset. So you should write it like this. This is a subset of A. It is not an element. There is no element like this present in the set. Okay. If you want to write it as an element, you should just state 5 comma 6 is an element of A like this. So there's a difference between these two. Okay. Last is 1, 2, 3 is subset. This is true. So your answer will be F, 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 T. So A is F, B is F, C is F, and D is T. Nobody got this right. Guys, try to understand the difference between subset and element of. This means it's an element of or belongs. This means it's a subset of. So this must be a subset. This must be a set. Is that fine? Okay. Next question is, similar looking question. A is 1, 2, 3, 4 in a set, 5. Okay. State true or false. State true or false. First statement is 3 comma 4 is a subset of A. Second one, 3 comma 4 belongs to A. Third one, set of 3 comma 4 is a subset of A. Option 4, 1 to 5 set is a subset of A. 5, 1 to 5 set belongs to A. Sixth one, 1 belongs to A. Seventh one, 1 is a subset of A. Eighth one, null set is a subset of A. And ninth one, null set is a subset of. Okay, let's go step by step. All of you, please answer. First one, is it true or false? Just write I true or I false. What do you think? Yes. That would be considered a single element. This would be a single element when you're writing the power set. Is this true or false? It's false. It's an element of set A, so it should ideally be this belongs to A. Why am I getting a mixed response? I just did an exercise, right? It's false. This is an element of the set. You can't write it as a subset. Subset, it is not a set itself. I mean, it should be like this to be called a subset of A. This would be a subset of A. Okay, wait, Vidyuta. First, let me clarify the first one. Why people are making mistake with the first one. Okay. Next one. This is true. Yes, this is true. This is correct. But this is not correct. First one was not correct. Second one is correct. Third one. Third one is true. Correct. As I already wrote here. Third one. Set of a set containing 3 by 4 is a subset of A. Okay. Fourth one. Fourth one. Fourth one is also true. Correct. So now 1, 2, 3, if you put this in a set, it will become a subset of A. But this is false. Fifth one is false. Is that fine? Okay. Sixth one. One is an element of set A. This is true. But one is a subset of A. This is false. Getting it? Okay. Seventh one. Null set is a subset of A. This is true. But a set of null set is a subset of A. This is false. Venkat, I think you interchange the answer. Eighth is true and ninth is false. Okay, let's move on to the next question. Write the set builder form for set A which contains 1, 2, yeah. No, set of a null set is not a subset of it because null set itself is a set. So you can say this is a subset of A, that's fine. But when you're saying this is a subset of A, that means A should contain null set as its element. Then only you can write this. Else you cannot write it. How do you write that in words, Venkat? Yeah, I understand you have identified the pattern. The pattern is the difference of consecutive term is natural numbers. That is fine. So you have identified that 1, 2, 4, 7, 11, 16, 22. This difference is 1. This difference is 2. This difference is 3, 4, 5, 6. But how do you write this as a formula? I cannot be descriptive, right? I have to write it in as simplistic formula pattern as possible. Any idea? Okay. I'll show you something very interesting. Let's say I decide to add these numbers. Okay, let's say I decide to add these numbers up till the last term, let's say the nth term. Let me call this as S. Okay, let's write the same term once shifted to the right. Okay, let us subtract these two. So this will become 0, this will become 1, this will become 1, this will become 2, this will become 3, this will become 4, this will become 5, this will become 6, up till Tn minus Tn minus 1 and a minus Tn. Correct? Let's bring this Tn to the left side. So it'll become Tn is equal to 1 plus 1 plus 2 plus 3 all the way till Tn minus Tn minus 1. Okay. Now here if you see there are n minus 1 natural numbers added. Correct? Whose sum we know that we all know from our junior classes that the sum till n terms is n plus 1 by 2, right? If you add 1 plus 2 plus 3 till n terms, we know that this sum is going to be n into n plus 1 by 2. Correct? If I sum the very same thing till n minus 1 instead, my sum will be n minus 1 into n by 2. Correct? So from here I can say that Tn would be 1 plus n minus 1 into n by 2. Okay? Take an LCM, so it will be 2 plus n square minus n. Okay? So this is basically nothing but n square minus n plus 2 by 2. Okay? So your nth term is going to be this. Now you can try out. Put n as 1. Put n as 1. You will get T1 as 1 minus 1 plus 2 by 2, which is 1. So this is the first term. Okay. Put n as 2, you get, put n as 2, you get second term as 1 plus, you can put it over here also if you want, 2 minus 1 into 2 by 2, which is again a 2. Correct. Put n as 3, you will get 1 plus 3 minus 1, which is 2, 2 into 3 by 2, which is 4. Put n as 4, you will get 1 plus 3 into 4 by 2, which is going to be 7, like that. Okay. So what I can do is, while writing the set builder form, I can say it contains x such that x is 1 plus n minus 1 by 2 for n belonging to natural number and n less than equal to, how many terms are there by the way? 1, 2, 3, 4, 5, 6, 7 terms. So I can write it as n less than equal to 7. Yeah, I subtracted both the series. I shifted it one to the right and I subtracted them. Is that fine? Probably they're not going to ask such complicated questions. It's just a, slightly more complicated version of writing the set builder form. Okay, next question. Again, there are two sets A and B. A has m elements, B has k elements. Okay. The number of subsets of A is 112 more than the number of subsets of B. Find M and K. The number of subsets of A is 112 more than the number of subsets of B. Find M and K. Seven and four, okay. Okay, let's check. Again, 2 to the power m is 112 plus 2 to the power k, same approach. 2 to the power m minus 2 to the power k is 112. So 2 to the power k into 2 to the power m minus k minus 1 is 112. Okay. Now this has to be an even number and a power of 2. This has to be an odd number. The only possibility is 16 into 7. So this implies 2 to the power k is 16. That means 2 to the power k is 2 to the power 4. That means k is 4. And 2 to the power m minus 4 minus 1 is 7. That means 2 to the power m minus 4 is equal to 8. That is 2 to the power m minus 4 is 2 to the power 3. That means m minus 4 is 3. So m is equal to 7. So k is 4, m is 7. Absolutely correct. Okay. Next question is set A is set A is 1, 2, 3. Set B is 2, 3, 4. Find intersection of power set of A and power set of B. Null set. Why? Why it will be a null set, Venkat? Okay. Oh, okay. Yeah. So basically, if you try to do it by a regress method, power set of A would contain null set 1, 2, 3, 1 and 2, 2 and 3, 1 and 3, and 1, 2, 3. Correct? Power set of B will contain null set 2, 3, 4, 2 and 3, 3 and 4, 2 and 4, and 2, 3, 4. Okay. Out of these commoner as these two are common, these two are common, these two are common, these two are common. That's it. Correct. So this is going to be nothing but null set 2, 3, 2 and 3, right? Now if you see this very closely, If you write the power set of this, what's A intersection B? A intersection B from here would be just 2 and 3, right? If you write the power set of this, you will get null set 2, 3, and 2 and 3. What does signify? These two are same. These two are same or not? So this brings a very important property. Please note this down. Power set of A intersection B is same as power set of A intersection power set of B. Is that fine? Okay. Okay. Fine. So I'll give you a question containing a null set also. Let's say there is a set which contains 1, 2, and a null set and a set of null set. Okay. Write down the power set of, let me just remove one element here. Yeah. Write down the power set of A. Done? Okay. Let's quickly look into this. So first write down all subsets of A. So by default you have a null set, correct? You will have a set of 1. You will have a set of null set. You have a set of null set, correct? You will have 1 and null set combined as a set. You have a set of 1 and the null set as a set. And finally, you'll have a set of null set and a set of null set as a set. So if you put a curly bracket around this, this will become the power set of A. So altogether, 8 answers should be there. 1, 2, 3, 4, 5, 6, 7. I think I missed out a set containing all of them. Yeah, 8 answers should be there. Okay? Is that fine? So, guys, all the best for tomorrow. Don't panic out, especially trigonometry question. Be very careful in choosing the means depending upon what you want to prove. It will be a very easy paper. Don't worry about it. It's a unit test only. Okay, just don't do silly mistakes. I don't want to hear I did a silly mistake. Silly mistake cannot be corrected. Okay, and do send me the paper after the school is over. Please send me a on the group itself. We can post the paper so that I can share it with other people also who were yet to write their UTs. Okay, so all the best. Over and out from my side. Practice from NCRT exemplar. Practice from NCRT exemplar and RD Sharma. Okay, these two books are sufficient enough. Okay, mostly they'll pick up questions from these two books itself. No, Venkat, I'll not be taking KVPY today because tomorrow you have a test, I guess, right? Tomorrow, which paper you have? Oh, English you have. Okay. Anyways, we'll take up KVPY session again. It's not a very big topic. Okay. So as of now, over and out from my side. All the best for English as well. Bye bye. All the best.